44 has an amplitude of 5 and a period of 2 pi. Remember, it's a sine curve, so this should come to your mind. So the zeros are at the beginning, the middle, and the end of the period. The maximum is 1/4 of the period, which would be at pi over 2, right here. And the minimum is 3/4 of the period, which would be at 3 pi over 2, right here. And then for the next period, the beginning would be 2 pi, then the middle would be 3 pi, and the end would be 4 pi. At 2 1/2 pi you would have a maximum, and 3 1/2 pi you would have a minimum. And so here are the two periods. Again, I drew them both on the positive, on the right of the y-axis, but you could draw one on the right, one on the left. 48 is another sine function. The amplitude is 1. The period is 2 pi over 1/4 because again, this could be written like this, so that you could see the b is 1/4. And so when you have 2 pi over 1/4, it ends up being 8 pi. And that's why you see the x-axis, the fourth tick mark is labeled 8 pi. And then this time I'm doing one on the left, one on the right. So the zeros for sine are beginning, middle, and end. And on the left side, beginning, middle, and the end is already there. The maximum for sine is 1/4 of the way, so it'd be at 2 pi, and again at -6 pi. And then the minimum is 3/4 of the way, so it'd be 6 pi, and then -2 pi. So here's the two. Here are the two periods. Oops, that's an arrow right there, and an arrow right here. Alright, so 52 is a cosine function, so what should come to mind is this picture right here. It has a amplitude of 3, period of 2 pi, and it shifts to the left. It has a phase shift of pi over 2 to the left. So I'm going to draw the y-axis. Pi over 2 would be right here. So that would mark like the beginning of the period. Okay, count 4 tick marks over, so 1, 2, 3, 4. At 3 pi over 2 would be the end of the period. Okay, and then the next period, because you have to draw 2 of them, 1, 2, 3, 4, would be at 7 pi over 2. Okay, so these dotted lines, you don't have to draw them yourselves if you don't want to, but I'm just drawing them as to help you see the shift to the left. Okay, so cosine has a 0 at the 1/4 and 3/4 of the way. So 1/4, 3/4, 1/4 of the next period, 3/4 of the next period. It has a maximum at the beginning and the end. So here and here and here. It has a minimum in the middle. So the middle would be at pi over 2 and at 5 pi over 2. And there it is. Connect the points, and there is the period, the two periods actually. So it goes back down, goes back down. Okay, so 56 is another cosine function. Remember, the cosine function looks like this. The amplitude is 2 with the reflection over the x-axis because the a is negative. The period is 2 pi over 4 pi, which is 1/2. The horizontal translation is 1 over 4 pi to the left. Okay, now 1 over 4 pi rounds off to 0.0796. Each square, like each little square here on this graph, is 0.0625 because it's 1/16. Every little square is 1/16. Based on the way I numbered the x-axis. So that means that the shift to the left is going to be a little bit more than 1 square. And that's what you see here with the yellow. It's a little bit more than 1 square to the left. Okay, So instead of being at 1/2, it's a little bit more than a square to the left. Instead of being at 2 pi over here, at 1 over here, it's a little bit more, more than 1 square to the left. Okay? So the zeros for cosine are 1/4, 3/4. So we're going to have, instead of 1/8, it's going to be about right here. Instead of 3/8, it's going to be about right here. Okay, maximum is one beginning and end, because this is a reflection, it's going to be right here and right here. Minimum is middle, right, which would be at a little bit over at 1/4, but because there's a reflection, it's actually up here on the top, but we go to a little bit more than 1 square over, right there. And then the other minimum would be here. And then, let's see, 1/4 about here would be the other 0. 7/8 about here. And then 3/4 about here. Notice all the dots are a little bit past 1 square to the left of their original location. Okay, so that's it. So now I just connect the points. And there are your 2 periods of cosine. For 60, we have an amplitude of 2 with a reflection over the x-axis, a period of 2 pi over 2 pi over 3. When you simplify that, you get 3, and a vertical translation of 2 units up. Now this is a sine graph, so it should look like this without, just without any transformation, something like that. So let's go ahead and draw this. So the zeros are beginning, middle, and end. So and I drew the yellow line to show the vertical translation. Okay, so here's the beginning, here's the middle, and here's the end. Okay, so that 3 is the beginning, and then there's the middle, and then there's the end. Maximum is 1/4 of the way, but this becomes a minimum at 3 pi over 4. 2 units from the yellow line, 2 units down, so that would be right here. At 9 pi over 4, we normally have a minimum, but because of the reflection, it becomes a maximum. Okay, at 15 pi over 4 is another low point because of the reflection, and at 21 pi over 4, it turns out to be a maximum because of the reflection. Okay, and this is, oops, my graphs get messier and messier, but you get the idea. Now, as far as labeling the x-axis, remember I start with a 3, then 3 divided by 2 is 3/2, and then half of 3/2 is 3/4, and then 3/4 times 3 over 1 is 9/4. Now I know that every tick mark is 3 pi over 4. So after this one, which is 12 pi over 4, I just add 3/4. So that gives me 15/4. I add another 3/4, that gives me 18/4, which reduces to 9/2. Then 18/4 plus 3/4 is 21/4. And then we end up on 6. Alright, for 64, the amplitude is 4 with the reflection over the x-axis because of the negative a. The period is 2 pi over 2/3, which is 3 pi when you simplify it. And then for the horizontal translation, I just thought it'd be easier to set the whole argument equal to 0 and solve for x. And you see the work right here. How I moved the pi over 3 to this side, and then I multiplied by the reciprocal of 2/3, which is 3/2, and 3/2 on this side. The 3's cancel, you're left with pi over 2, and over here, of course, all this cancels, so there's a phase shift of pi over 2 to the right, because x turns out to be positive. So here you see, notice how the tick marks are every 3 squares instead of every 2 squares as I usually do it. The reason for that is because of the 1 pi over 2 translation, and made it a little bit easier just to count 2 squares and to draw the line, because that's where pi over 2 would be, because this is where 3 pi over 2 would be. So this is 1.5 pi. So this would be 1 pi and then 1.5 pi. So it'd be, I thought it'd be easier that way to count by threes for every tick mark. So I went ahead and I drew the beginning of the period here, the end of the period here, and we'll do one part of it here and then one part of it here, okay, to make up 2 periods. So for sine, the zeros are beginning, middle, and end. So here, middle is no longer 3 pi over 2. It's going to move over 2 squares to the right, and right here. Okay, so then the next one would be, let's see, 3 right here, and then let's see, we're not going to see the next one. It's going to be 1, 2, right here. Okay, maximum would normally be 1/4 of the way, but because of the reflection, it's to the bottom. It's the minimum. So that would be right here. Again, 2 squares to the right of 3 pi over 4. And then the minimum, which is now the maximum, would be right here. Okay, so right here we have -4, and then to the left we have 1, 2, 3, 4 right here. Okay, so you have, starting backwards, starting from the back to the front. I'm going to go into the words, into the numbers there. Okay, so here we have one full period. You know, we normally call one period right there. Then I drew half right here and half right here. And that's a total of 2 periods. Alright, so for 68 we have amplitude of 5, period of pi, because the coefficient of x is -2, so we just take the absolute value, which is 2, and put that in the denominator here. So the period would be 2 pi over 2, which is pi. The vertical translation is 6 units up from here. And for the phase shift, what I did here, as you can see on the right side of the equal sign, I factored out a -2 from the argument from here. And when you do that, you get this. And I'll bring you back to the bottom of the screen here. Remember the even odd properties that say that if you have theta and negative theta, with the x's don't change, the y's do. They're opposite of each other, but the x's are the same. And remember, cosine is the x coordinate. So this negative right here, it's as if it wasn't there. It equals to this. It equals to +2. Why? Because positive theta gives you x, and negative theta gives you x. Gives you the same thing. So the cosine of this negative angle is equal to the cosine of the positive angle, +2. So we're just going to graph this one, which is the same as this one right here. They're equivalent, the same graph. So I drew the yellow line here for the vertical translation. It's a cosine graph, so we know that. Oh, and then there's a I almost forgot, there's also a phase shift pi over to the right. So right here, okay, and then instead of pi, it's going to be at 1 1/2 pi, so 3 pi over 2. And then the other one would be, instead of 2 pi, it'd be at 5/2 2. 5/2 pi, I'm sorry. There. Okay, so the zeros for cosine are 1/4 and 3/4 of the way. So at 3 pi over 4 and 5 pi over 4, and again at 7 pi over 4 and 9 pi over 4. Okay, the maximum, there is no reflection here, so the maximum is the beginning and end. So start from the line y equals 6, from the yellow horizontal line, you count 5 units up. So we land on 11. So at 3 pi over 2 it's 11, and 5 pi over 2 it's 11. The minimum is in the middle. So the middle in this case is pi, And so we go from the yellow line, horizontal line, we count 5 down. So that's going to be at 1. And again at 2 pi.